Hello, everyone. Thank you for joining our session. My name is Beaudin. I run the A3i program at DDN Storage. And in this presentation, we'll discuss how HPC at scale is enabled by DDN A3i solutions and NVIDIA SuperPOD. So to put a bit more context around the session, my team and I have designed and deployed at-scale data platforms that power the largest SuperPOD currently in operations around the world, including the SuperPODs operated by NVIDIA for their own internal use. We were asked to present and share with you some of the key considerations for achieving best possible results with at-scale applications running on a SuperPOD. So before we continue, I want to quickly mention that you'll find my direct contact information on the slides. I'd really like to get your feedback on the session, as well as any questions or ideas that come up for you along the way. We're very focused on designing and delivering data solutions that enable applications to get the most from SuperPOD deployments. So please reach out if you have any projects or if you'd like to consult with us. We'd love to engage with you and your team. For those of you not familiar with DDN, we provide at-scale data platforms, a full gamut of turnkey products, end-to-end solutions, and expert services. For over 20 years, DDN platforms have powered the largest supercomputers in the world, as well as the most demanding data-intensive environments in industry, academia, and government. Our platforms are widely recognized to deliver fastest performance, limitless scalability, and the most flexibility. The capabilities and the agility of our products make it very simple for our customers to enable and accelerate all their modern workloads, including AI and HPC. So with systems at scale like SuperPOD comes responsibility for us to deliver maximum uptime. Our platforms are deployed for continuous operation in the most mission-critical environments around the globe. And for over 2 decades, our platform has proven resilient and reliable in even the most extreme situations. Best of all, the DDN teams has a very deep understanding and a very unique experience with at-scale infrastructure, applications, and workflows. We bring unrivaled expertise for SuperPOD projects. We have proven ability to execute and deliver data solutions built for scale. Today, there's a very strong technology partnership between DDN and NVIDIA. Our joint customers have repeatedly proven that combining DDN data platforms with NVIDIA GPUs delivers massive acceleration for data-intensive workloads at scale, including HPC, analytics, and deep learning. We launched a joint integration program almost 2 years ago, DDN A3i powered by NVIDIA. A3i stands for Accelerated Any-Scale AI. With A3i, we deliver fully optimized, easy-to-deploy data platforms that integrate seamlessly with GPU systems like the NVIDIA DGX1 and DGX2. We designed a portfolio of data appliances that are optimally tuned for GPU-accelerated big data workloads like HPC, analytics, and deep learning. Our A3i appliances provide many benefits for customers: accelerated application performance, full end-to-end workflow enablement, and seamless scaling. They have robust data protection built in, and they're backed by a full gamut of expert services from DDN. So with A3i, we bring all the same technology that we use to power the largest supercomputers in the world into a turnkey appliance. The entire package is easy to deploy and manage. It connects seamlessly with DGX systems and containerized application. And the A3i program has been very successful in enabling customers running data-intensive workloads in a wide variety of environments around the world. We've deployed A3i appliances at all scale, from a single DGX system all the way to the largest SuperPOD in operation today. Earlier this year, we released a new generation of A3i appliances, the AI400X and the AI7990X. The AI400X is an all-NVMe platform. It ships fully configured with 24 NVMe drives. It's offered in different capacity increments from 30 to 256 terabyte usable per unit. It delivers a whopping 48 gigabytes per second of throughput and 3 million IOPS to clients. The AI400X is the ideal building block for an all-performance file system to support the most intensive workloads without any compromise. It can also be coupled with the AI7990X, which is a hybrid capacity appliance that's ideal for holding on to very large amounts of data in the most optimal cost density configuration possible. The AI7990X is offered in 1, 2, and 4 petabyte capacity increments. It delivers well over 24 gigabytes a second of throughput and 750,000 IOPS to clients. The AI7990X is the ideal building block for a large data repository to use in workflows like deep learning that require assembling and maintaining massive collections of curated datasets. Both appliances connect to clients over a high-performance, low-latency RDMA-capable network, usually HDR 100 InfiniBand or 100 Gig Ethernet. We've tested these appliances at scale, providing data access to over 96 DGX2s simultaneously and achieving the full peak performance capabilities of the appliances. So these are two very powerful building blocks for at-scale data platforms. You can start with a single appliance and add more as your needs grow. You can build all performance, all capacity, mix them together, and we'll discuss some standard strategies for SuperPOD later in the session. And of course, DDN engineers are available to help guide you through the design process. Having a fully integrated A3i appliance enables us to achieve a reliable, predictable experience in the field. This makes it very simple for us, our partners, and our customers to architect a data platform that delivers the level of performance, capacity, and capability that's required and expected from the solution. At the same time, it makes it much simpler to plan for the future with confidence, knowing how the data platform will scale to meet evolving workflow needs. Speaking of scale, as I mentioned earlier, DDN A3i data platforms are deployed with the largest SuperPODs currently in operation around the world, including the SuperPODs operated by NVIDIA for their own internal use. A majority of deployments leverage the AI 400X as their primary data tier because it provides massive performance and also huge flexibility. Having flexibility is particularly advantageous if you're planning to deploy a SuperPOD as a shared resource. For example, we have a customer, Life Sciences Research Institute, that deployed DDN A3i solutions with a large number of DGX nodes. They use the DGX cluster as part of both genomics and microscopy workflow. So on one hand, genomics involves lots of small random application I/O to datasets made up of millions of kilobyte-sized files. On the other hand, cryo-electron microscopy involves large sequential application I/O to datasets made up of dozens of gigabyte-sized files. So those are two very different sets of requirements for their data platform, complete opposites, in fact. Yet DDN A3i fully satisfies their genomics and microscopy workloads simultaneously and without compromise. With the AI 400X as a primary data tier, a SuperPOD operator can run different types of applications using a wide variety of data sets simultaneously and still achieve the best performance possible from all the GPUs. DDN A3i brings simple, flexible application enablement at scale, and that's extremely valuable to SuperPOD. DDN A3i solutions actually make SuperPOD fast and easy to deploy. NVIDIA provides very strong guidance that covers the compute and network components of a SuperPOD at different scales. DDN enhances and completes the SuperPOD solution by providing the data platform components needed to actually operate the SuperPOD at its full potential. We also cover end-to-end application workflows by considering critical data operations around the SuperPOD as part of our overall solution, such as data ingest, data curation, backup and archive, etc. And so we simplify the SuperPOD data platform design process by leveraging a modular approach. Our pre-configured A3i appliances deliver predictable performance, capacity, and capability. DDN also provides fully validated reference architectures to help accelerate your design and give you confidence about the performance of the system as it scales. And once you're ready to deploy, the appliances arrive on site, already configured and ready to be integrated in your environment. We recently delivered 10 AI 400Xs and had the systems integrated with a DGX2 SuperPOD in less than 4 hours from box to production. And this contrasts heavily with traditional art infrastructure deployments for supercomputers, which can span months or even years. SuperPOD deployments can also benefit from the integration work that we furthered with DGX, making it simple to interface DDN appliances with DGX systems and containers to get to production quickly. And as part of the A3i program, we've worked very closely with NVIDIA to deliver a streamlined end-to-end deployment process for SuperPOD. So we recognize that SuperPOD are large projects, and we provide comprehensive expert services with NVIDIA and our partners globally to guide you through the design, deployment, management, as well as full stack optimization process. DDN stands with its customers to help achieve success and provides unrivaled experience and expertise when it comes to SuperPOD. Another unique advantage of our A3i appliances is that we integrate several layers of the solution stack within a single unit. So this significantly reduces the number of network and server components that are otherwise required to build an at-scale data platform. For our customers, a fully integrated A3i appliance means simplified deployments, less complexity in infrastructure, and also significant cost savings across the board. Having an integrated appliance also gives us a tremendous ability to fine-tune and fully validate the solution. Our engineering teams optimize all hardware and software layers within the appliance so that we get the most capability from the system. By tightly coupling the hardware and software together, we're able to achieve the full potential of all NVMe drives in the appliance. By eliminating all the overhead in the I/O path, we deliver data to applications running on GPUs with high throughput, massive concurrency, and lowest possible latency. With some workloads, for example in financial services, faster data response and application performance directly translates to massive increase in revenue. In real-time signals processing, reduced latency can prevent a catastrophe, be it with autonomous vehicles or for public safety missions. Our A3i solutions use a shared parallel architecture to enable and accelerate applications running on large multi-node compute clusters like a SuperPOD. This allows us to deliver superior performance, scalability, and reliability than legacy enterprise architectures and protocols. In a traditional enterprise architecture like NAS, the data transfer path between a client and a storage node is heavily serialized. This is a crippling bottleneck for any kind of data-intensive workload, especially at scale. With NAS, a storage device is presented by a server to a client using a file-sharing protocol like NFS or Samba. Both the server and the client are connected to a network, usually through a single link. The client can write and read data to the storage device through the server. The process is very simple and works very well for handling small data volumes or for applications that have modest I/O requirements. However, the architecture provides limited performance, scalability, and reliability. Even in a cluster NAS architecture, the client always communicates through a single server, which splits and redirects the data requests among other server nodes in the cluster. This creates lots of back-end operations, which adds even more overhead and delay for the applications running on the client. It's very difficult and expensive to scale beyond the limitations of a traditional enterprise architecture and file sharing protocol. These types of data platforms are obviously not adequate to meet the requirements of at-scale systems like a SuperPOD. And in fact, if you look at the top 500 supercomputer list, you won't find any traditional enterprise data platforms or manufacturers listed. Throughout the 90s, supercomputers transformed from being monolithic machines to clusters with multiple powerful compute nodes connected through a high-performance network, just like a superpod. And for over 20 years, DDN has furthered the development of a shared parallel architecture to adequately enable data-intensive applications running on modern compute clusters. In fact, DDN technology appears in over two-thirds of systems on the top 500 supercomputer list. So with A3i, we bring our shared parallel architecture to DGX and SuperPOD. Let's dive a bit deeper. For example, inside an AI 400X appliance, we present NVMe devices to embedded servers. There are multiple servers running on two individual controllers in an appliance. All devices are fully connected, so we maintain data availability if one of the controller or server becomes unavailable. Both the appliance and DGX client nodes connect together through multiple links over a high-speed InfiniBand or Ethernet network. The clients can read and write data to the appliance through multiple parallel paths that are managed seamlessly by the DDN A3i software. These parallel data paths deliver data with high throughput, low latency, and massive concurrency directly to GPU memory. And as part of the DDN architecture, we extend those parallel paths from the GPUs all the way to the raw NVMe devices within the appliance. The true end-to-end data parallelism from the drives to containers running on GPUs translates to faster application performance at scale. The shared parallel architecture scales seamlessly and linearly. As additional appliances are joined to the file system, both the storage capacity and performance for client data transfer increase. The shared parallel architecture has unique characteristics of DDN data platforms. It enables workloads to run seamlessly on multiple GPUs and even scale across multiple nodes and maintain peak application performance. Some of our SuperPOD customers distribute their applications on over 96 nodes simultaneously, which is over 1,500 GPUs. By nature, the GPU architecture provides facilities for massive processing concurrency. And by coupling that with a highly parallelized data architecture, we achieve a very powerful combinations for applications. This is the foundation of how HPC at scale is enabled and accelerated by DDN A3i solutions and NVIDIA SuperPODs. As part of the A3i program, we continuously engage with our technology partners and our customers to understand how common applications running on GPUs behave. We run an extensive program to measure and improve application performance for a single node with multiple GPUs and multiple nodes each equipped with multiple GPUs. In almost every test, the DDN shared parallel architecture brings impactful acceleration to these applications. In the case of deep learning codes at scale, training frameworks running on GPUs coupled with DDN A3i consistently achieve higher training throughput rates and also complete more rapidly. The increased efficiency is especially significant with a large system like a SuperPOD, as it translates to more total time available for user jobs and no GPU cycles wasted waiting for I/O to complete. We've also studied at-scale application performance using the original pod architecture from NVIDIA. The limitations of traditional enterprise architecture and protocol that we discussed earlier become very apparent when the applications are run over multiple nodes and GPUs. With an NFS-based data platform, once the protocol performance limit is reached, the distributed application performance does not improve as more GPUs are engaged to participate in the workload. So this wastes valuable computing resources and imposes an artificial barrier for application scalability. With DDN, the performance of the application scales up linearly as more GPUs are engaged. This dynamic is very important to consider in a SuperPOD environment where an application may be engaged over a large number of nodes. To be effective, the data platform for SuperPOD must be able to scale and maintain GPU saturation. The DDN A3i shared parallel architecture is proven to do this exceptionally well. Our team has worked very closely with NVIDIA's systems engineering group to optimize DDN appliances like the AI400X for SuperPOD with DGX. We deployed multiple appliances in their laboratories in California. Over several months, NVIDIA engineering teams engaged a very comprehensive test program to fully evaluate the interoperability, the performance, and the capabilities of our A3i appliances at scale. They examined the behavior of data-intensive applications like deep learning running on multiple nodes within a SuperPOD and measured the impact of our shared parallel architecture on performance. Overall, the results of this long exercise validate that the DDN A3i data platforms truly deliver the performance required for at-scale application enablement on SuperPOD. After completing the test program, NVIDIA published a SuperPOD reference architecture document, which describes some of the protocols followed and results that were achieved. It's available from both the DDN and NVIDIA websites. I encourage you to download and review this document, as their tests outline some of the most important characteristics to evaluate in the data platform built for scale. The NVIDIA teams drew 3 important conclusions from their testing. In their words, first, the DDN A3i appliances deliver incredible sequential and random read performance as required by the heaviest deep learning workloads. Second, the data and metadata performance scales well from 1 to 96 nodes with no degradation as the number of nodes and threads increases. And third, that the DDN AI400 is a fully integrated platform that's easy to deploy. They also note that DDN provides excellent technical deployment and support services. So the conclusions from this report are extremely validating for DDN and demonstrate that the A3i approach for building at scale delivers proven advantage for applications running on a large cluster like a SuperPOD. We've deployed A3i solutions in several multi-DGX and SuperPOD environments. As part of the design process, we consider many parameters to ensure that we deliver the optimal configuration for the site. We look at things like the number of DGX nodes deployed in the cluster, the volume of data being stored and processed, and the types of applications and workflows that will be engaged by users of the system. Oftentimes, it's a very collaborative and iterative design process. The DDN team brings both technology and experience to the conversation. It would take a whole series of sessions to cover reference architectures and recommendations in proper depth. But for our session, I want to discuss high-level approaches for A3i architectures with SuperPOD. Across projects today, we see 4 common base A3i architectures with SuperPOD and multi-DGX. The first option is an all-NVMe solution. So we provide a number of AI400X appliances grouped together as a single file system and directly connected to all the nodes in the SuperPOD. This provides a workspace for users and application that delivers highest possible performance for all workloads and data types. Flash provides an uncompromising level of flexibility for SuperPOD operators, and all NVMe has been the choice for the largest SuperPODs in operation today. The cost of Flash has evolved to a point where it makes economic sense to deploy 15 to 20 petabytes of all NVMe to support a SuperPOD, and ensure that all GPUs are fully saturated. The second option is a multi-tiered solution. We provide a certain number of AI 400X appliances that act as a high-performance workspace for application and users, coupled with AI 7990X appliances that act as a deep data repository. The entire storage system is accessible by all nodes in the SuperPOD. With A3i, we have the ability to deploy a single file system with multiple tiers and use hot pools features and stratagem engine to control data residency. So in this architecture, a user sees a single instance of the file and can elevate the underlying data from the capacity repository to the flash workspace with a simple command. The application can access the data from the flash tier, which provides best performance, and can save any output data back to the deep repository if long-term storage is needed. So this type of architecture is still very much in demand with some traditional HPC and deep learning customers. We can scale both the performance and capacity tiers independently and with no practical limits. The third option is a multi-site option. We provide a certain number of AI 400X appliances that act as a high-performance workspace for application and users. The AI 400Xs are installed in the same data center as the SuperPOD nodes and connected to them. We also provide another system, typically built with AI 7990X appliances, that acts as a deep data repository, but is installed in a secondary data center. DDN provides high-performance data management tools to move, copy, and synchronize data between the two data centers. Now, there are variations on this options, including more data centers if you're doing edge-to-core deep learning workflows. However, the main driver for this architecture is infrastructure constraint at the SuperPOD data center. The compute infrastructure can consume a whole megawatt of power, and so we've had to design a split system where the performance tier lives close to the compute and the deep repository is at another site to divide the load and meet infrastructure capacity of the different data centers. Finally, a fourth option includes a multi-cloud integration. So we provide a certain number of AI 400X appliances that act as a high-performance workspace for application and users and is connected to all the nodes in the SuperPOD. And DDN provides data management tools to move, copy, and synchronize data between cloud services and the SuperPOD storage. We can also extend those capabilities to manage data between clouds. Several of our large multi-DGX customers requires an interface with private and public cloud services, which act as long-term data repositories and also general purpose compute burst space. We can combine all of these options to meet end-to-end workflow requirements around a SuperPOD. And today, many customers opt for an all-flash configuration, so they're guaranteed best performance and flexibility at good economics, and plan to scale with other configurations as their needs grow over time. And networking is a core component of a SuperPOD, and we've seen different implementations based on the application and workflow that the customer is pursuing. DDN A3i appliances integrate the latest generation InfiniBand and Ethernet technologies for connectivity. InfiniBand technology is usually the preferred technology for at-scale cluster deployments. InfiniBand fabrics are the critical backbone for SuperPOD and deliver both high bandwidth and low latency data transfers for high performance storage and applications. So as part of the A3i program, we've augmented our software with a multi-rail feature that greatly simplifies and optimizes the A3i networking stack. Multi-rail enables grouping of multiple network interfaces on a node to achieve full aggregate throughput capabilities. So the feature also provides dynamic load balancing and actively monitors link health for rapid failure detection and automatic recovery. So with multi-rails, we can immensely simplify the network configuration for a SuperPOD to plug and play level, yet still maintain the full capabilities of our networking stack for more advanced setups. So as part of a design phase for a SuperPOD, a DDN engineer will consult on fabric technology and topology to ensure that we achieve optimal performance and easy integration with A3i appliances. As part of the partnership with NVIDIA, DDN collaborates very closely to the development of innovative advanced technologies like GPU direct-to-storage, or GDS. And in short, GDS enables a direct path to transfer data between GPU memory and data storage via the node's network interfaces. This eliminates unnecessary memory copies, lowers CPU overhead, and reduces I/O latency. And this significantly increases application performance. So the GDS data path bypasses the host CPU and memory, which removes an I/O bottleneck. And working with NVIDIA, we've demonstrated that an application running on GPUs in a single DGX2 node can achieve over 80 gigabytes of read throughput. That's almost double than when using a traditional I/O path going through CPU and memory. So by implementing this bypass natively in the DDN A3i software, it enables DDN to provide for larger, scalable node designs beyond DGX2 and future-proofs the DDN A3i software. So this feature is fully implemented in current generation A3i appliances and will be available for select DGX customers as part of an upcoming beta program. Please contact me if you're interested in participating. We tested GDS performance at scale using multiple DGX2 nodes. The goal is to validate linear scaling at peak node performance. We deployed 10 AI 400s as a single file system, which provides up to 480 gigabytes per second of aggregate read throughput performance. We ran an I/O-intensive application on the GPUs in each of the 5 DGX2s, and as we engaged the applications on each of the node, we showed linear scaling in 80 gigabytes per second increments. With all 5 nodes engaged, the application achieved close to 400 gigabytes per second of aggregate read throughput with the data platform. And so this test shows that using GDS, we can satisfy peak I/O performance with a distributed application running across multiple DGX2s. With sufficient appliances, we can deliver this level of performance to all nodes in the DGX2 SuperPOD. And looking beyond peak performance, DDN A3i provides tremendous flexibility with its data services capabilities. So in addition to direct high-performance native parallel data access, DDN A3i can also be extended to file sharing protocols for utility and S3 protocol for hybrid file object deployment. The DDN A3i S3 data service is a very unique capability. Data can be accessed both as a standard file and as an S3 object simultaneously. We have several customers who engage deep learning programs that ingest data through an S3 interface directly to a data platform. This is very common with IoT and autonomous vehicle development, where edge sensors write data as objects through an S3 interface. However, the data processing, training, and other deep learning applications running on the SuperPOD need access to that same data as a file. So with DDN A3i, S3 data services, we bring the ability to provide both the file and object interfaces for the same data, which is extremely useful for many deep learning end-to-end workflows. And as with all DDN products, the S3 interface architecture is extremely fast, scalable, and reliable. Another very important DDN A3i feature is the built-in analytics engine. This is extremely valuable for large clusters like SuperPOD. We've instrumented every layer of the A3i appliance to provide real-time information to a central analytics facility. That covers everything from hardware status to network counters, all the way to in-container job application performance. Having full stack metrics allows us to discover insights and trends about the production environment. We cover basic administrative features like predictive failure analysis and intelligent call home for support. More interestingly, we're able to monitor data platform utilization and performance for a specific user, a specific group, or a specific job. We provide very fine and detailed metrics that a SuperPOD operator can use to optimize infrastructure and application performance, identify misbehaving users and nodes, and also capture data points for business intelligence. For example, with this data, you can implement an automated chargeback system for users based on compute and storage utilization. We include a base monitoring capability with every A3i appliance, and we can expand that into a comprehensive centralized monitoring solution for larger deployments. DDN is also investing significant effort to help advance the containerization of AI and HPC. As part of our integration with DGX, we've developed the ability to mount an A3i file system directly within a Docker container at runtime. This can extend our shared parallel architecture all the way to a specific container running on a SuperPOD node. This brings significant application performance benefits by enabling low latency, high throughput parallel data access from a container. As well, this provides a simple yet very solid mechanism to enforce data segregation by restricting data access to the container and preventing the rest of the DGX node from accessing data through the mount. Best of all, the integration is seamless. There's no need to modify the application container, and the capability to mount the A3i file system is injected in the container at runtime through a DDN provided wrapper. The additional software is inserted on the fly as part of the regular Docker startup. Data is accessed through a standard POSIX interface, which is highly interoperable for most applications and very familiar to users. Containers bring security challenges, adding higher chance of malicious root access from clients. So we have several control facilities in A3i, including the ability to enforce a global root squash to prevent unauthorized data access or modification from a malicious user, even if a node or a container are compromised. Another important consideration for our session today is digital security. It's a very sensitive topic for all of our customers in industry, in academia, and in government. Part of enabling at-scale application involves having the ability to protect information, be it at rest or while it's in use. DDN A3i solutions include a very broad portfolio of capabilities that allow you to control and monitor how information is accessed and stored and by whom. It gives you the tools you need to implement the apparatus to achieve your digital security objectives. Usually when considering a deployment at SuperPOD scale, there's a need for structure, even basic, to ensure good working behavior between the users of the system and that the right information is available to them. DDN A3i provides a series of 4 core security mechanisms around visibility and control. The first mechanism is authentication. It allows to identify a specific user, a specific container, or a specific node in the SuperPOD and grant or deny them access to data. We also provide mutual authentication capabilities. Some high security processing applications commonly found in financial services and signal processing require that the data platform identifies itself correctly for the application to execute. The second mechanism is access control. Once a user is authenticated, we provide extensive facilities to control which portions of the data platform can be accessed and how. We provide discretionary access control where user groups are allowed to read and write data based on file system permissions. A common deployment strategy with SuperPOD is to keep original data sets read-only so users cannot modify the source data, however also providing a workspace with full read and write capability for users to save output from their applications. The third mechanism is encryption. We provide encryption at multiple levels to prevent data theft. We can supply A3i appliances with self-encrypting drives where data is encrypted internally and held securely while it's at rest. We can also encrypt data on the wire to protect data transfers between nodes and prevent man-in-the-middle attack. For many organizations, having secure communication between the storage appliance and the SuperPOD nodes is a requirement, especially if there's an interface with a larger network. Encryption is also very useful if you're looking to deploy SuperPOD in a shared environment where sensitive information is being handled. The fourth mechanism is audit facilities. We have the capability to record all activity on the file system, every read, write, and modify operation. That's a very sizable challenge considering that millions of operations can happen simultaneously across a SuperPOD. We can record all of it in a tamper-proof database, and we can forward the events to an external logger. We can also record failed access attempts, which is often the kind of information that digital security officers will want to audit. We also have node-level audit controls. We have customers who segment their SuperPOD between open general purpose space and various levels of classification. The controls in A3i allow them to increase audit levels of certain nodes based on the requirements for the specific level of classification that the node is assigned to. DDN A3i makes it easy to deploy a secure SuperPOD. The extensive support for containers and comprehensive security features in DDN A3i make it very simple to operate a true multi-tenant environment at scale. The majority of DGX and SuperPOD customers that we work with today take advantage of our multi-tenancy capabilities to share their high-performance computing infrastructure securely among a group of users. In their environment, multiple users consume resources for a period of time to execute an application, and depending on the project, that could be a portion of a node, a full node, or even multiple nodes. So multi-tenancy provides quick, seamless, dynamic DGX resource provisioning, and the DDN A3i multi-tenancy features make it simple to share a SuperPOD across a large pool of users and still maintain secure data segregation. Multi-tenancy also allows a SuperPOD operator to get best economics and operational efficiency by consolidating HPC as a single operation. Among other things, it eliminates resource silos, complex software release management, and unnecessary data movement between data storage locations. And all of this while maintaining a very robust digital security apparatus and maximum uptime in mission-critical environments. DDN A3i brings a very powerful multi-tenancy capability to SuperPOD and makes it very simple for customers to deliver a secured, shared innovation space for at-scale data-intensive applications. And so I want to finish the session by tying all of this to a customer use case. So collaboration is a catalyst to advancements and breakthrough discoveries for many fields, including life sciences. And DDN provides end-to-end workflow enablement and acceleration for core research using A3i. And so we have a broad set of technology partners globally in the life sciences space, including the major instrument manufacturers for microscopy and genomics. And we've published several white papers that show application acceleration when running on DDN A3i with NVIDIA DGX. They're available from our website and also very relevant in the context of SuperPOD deployments supporting core life sciences research. We've recently completed a nice integration in life sciences with Tomo in Japan. We're very proud of this project and for the opportunity to participate. Tomo uses its very large high-performance computing infrastructure to engage in broad-spectrum genomics research. They draw on over 30 petabytes of research data as part of their experimental pipeline. And in short, they've accelerated their genomics pipeline over 40 times using an end-to-end DDN A3i solution with NVIDIA DGX and Parabricks. The achievements for Tomo is very significant and speaks loudly to the powerful application enablement that comes by combining DDN A3i solutions with NVIDIA DGX for life sciences workflows. Let's build on that example and bring it to SuperPOD scale. The current situation with the COVID-19 pandemic makes a strong case for deploying accelerated at-scale life sciences research solutions. The combination of DDN A3i with NVIDIA SuperPOD makes for a very compelling combination. A DDN data platform can scale and allow you to capture large volumes of data in real time from multiple sources, genomic sequencers like microscopes, radiology imagers, cryo-EM microscopes, crowdsourced information. And the DDN shared parallel architecture allows you to access all this information immediately from every node in a SuperPOD and engage different types of application, specialized science programs, analytics, deep learning, to mine the data and achieve fastest time to result. So DDN A3i allows you to store, process, analyze, and visualize all your data from a single platform. Combined with SuperPOD, we can deliver a solution that enables high-throughput screening, accelerated drug development, permit at-scale population studies, and global collaboration in the search of breakthrough discoveries that will improve patient outcomes globally during this pandemic. And best of all, with the DDN A3i and SuperPOD reference architectures, we can apply a solution like this very quickly and very easily anywhere in the world. DDN works very closely with a network of NVIDIA certified partners globally to deliver fully integrated A3i solutions with NVIDIA DGX1 and DGX2. As part of the A3i program, we actively engage with our partners' teams to ensure that they're fully equipped to provide the most optimal data platform solutions for DGX projects. For SuperPOD, we're working very closely with NVIDIA and our partners WWT and Atos to deliver turnkey solutions for customers. Both Atos and WWT have successfully deployed DDN products at scale for a wide variety of projects, and our collaboration enables us to deliver full service engagements, including end-to-end workflow optimization and expert consulting for HPC, analytics, and deep learning applications operation at a scale. Our partners are backed by DDN's global field engineering and support organization, which is widely recognized for its deep expertise, experience, and commitment to customer delight. To close the session, the combination of DDN A3i solutions and NVIDIA SuperPOD delivers massive enablement and acceleration for all big data workloads at scale, including HPC, analytics, and deep learning. Already today, we have customers in academia, industry, and government all around the world who benefit from the tight technology integration between DDN and NVIDIA. As we've discussed throughout the session, DDN data platforms consistently deliver best results for at-scale HPC infrastructure and workflow. The performance, the scalability, and the advanced capability of the DDN A3i shared parallel architecture help you truly achieve the full potential of an NVIDIA SuperPOD deployment. DDN is proven at scale and gives you the flexibility to achieve the most from applications running on SuperPOD with no compromise. If you're interested in learning more, I invite you to take a look at our website, ddn.com/A3i. There's a lot of technical material published through that portal. It's also a great space to watch. We're constantly adding new information and refreshing content with our latest technology solutions and customer success stories. Also, we're very interested in hearing from you directly. Whether you're working on a specific project or you'd like to follow up on the session with a question or have a discussion, please reach out and engage with us. We look forward to it. Thank you for your attention. We hope you enjoyed the session.